This problem describes a solid of revolution created by rotating the given region about the y-axis, and we are asked to find the volume of this solid. We begin with a sketch of this region in 2D. For this, we need a y-axis and an x-axis. Y equals to square root of x is our familiar root function that starts at the origin and grows something like this. Let's make sure we also label this on the graph. X is equal to 0 is the y-axis, and here is the line y is equal to 2. Now that we have sketched the three curves, we have found the enclosed region and we will shade it. We also indicate the axis of rotation, which is our y-axis, and one general disk that will help us set up the integral to calculate the volume of the generated solid. So here is a general radius that produces this general disk. Let's remind ourselves that in general the volume of a solid of revolution with the disk method is found with the integral from a to b of the disk area integrated with respect to a suitable variable. Now the integral from a to b is the one through which all of our disks run, which in our case is from 0 to 2. And because these disks cut the y-axis, we have to integrate with respect to y. The disk area is pi times r squared, and our radius is x. Now we have a problem, because we are asked to integrate with respect to y, but we have an x in our integrand. We should take this function y is equal to square root of x and solve it for x. So we square both sides and we get that x is equal to y squared. Now we can continue with our integration. So this is equal to the integral from 0 to 2 of pi times y squared, and squared again is to the power of 4, integrated with respect to y. We can readily find an antiderivative, which is y to the power of 5 all over 5, evaluated from 0 to 2. We readily see that we get a value of 0 at the lower bound y is equal to 0, and so our volume is equal to 2 to the power of 5, which is 32, all over 5 times pi cubic units.